History of universe explained 13.8 billion years ago. Imagine everything, all that exists in the whole universe, squeezed into a point smaller than a pinhead. Then, around 13.8 billion years ago, this infinitely small point suddenly exploded, the so-called Big Bang. It wasn't so much an explosion like a bomb, but more of an extremely rapid expansion that gave rise to all space, time, and matter as we know them today. In an incredibly small fraction of a second, the fundamental forces of gravity and electromagnetism began to detach themselves. Small particles, quarks, and electrons started forming in this very hot environment at about 10 circumflex 32 degrees Celsius, far from anything imaginable on Earth. This was a very significant event due to the great heat and speed of expansion that it initiated, setting the stage for everything that would come after. As the universe was expanding, it started cooling. This cooling allowed quarks to come together to form protons and neutrons, and somewhat later, these formed into the first atoms, basically hydrogen and helium. It was then that the current stars and galaxies began forming. 13.7 billion years ago. Right, so immediately after the Big Bang, the universe was still very hot and was part of an extremely rapid expansion. But within just a few minutes, it began cooling enough for consequential action to take place. Protons and neutrons, small building blocks of atoms, began smashing into one another. When they did, they formed atomic nuclei of the first elements: hydrogen, helium, and a small amount of lithium. Such a process is aptly called nucleosynthesis. The elements thus formed are crucial since they are the source materials for all structures in the universe, from stars to galaxies. Since the universe was continuously expanding, it was cooling down too much for more nuclear reactions to take place. That means that heavier elements could not be formed just yet. So hydrogen, helium, and lithium had been predominant constituents of the universe for a very long time. These light elements would then form the first stars. 13.4 billion years ago. All right. So let's take a universe that is now 380,000 years old. By this time, it had cooled to about 3,000 degrees Celsius. This cooling was very important because it allowed electrons to combine with protons and form neutral hydrogen atoms. This process is known as recombination. Before this recombination, the universe was like a thick fog wherein light couldn't travel very far. Light traveled freely once these neutral atoms had formed, and the universe became transparent. This light still lingers in our times and is now known as cosmic microwave background radiation. It's kind of an early snapshot that gives scientists some sort of view into what it was like back then. This cosmic microwave background is everywhere in the universe, and we can detect it with special instruments. It is one of the key pieces of evidence for the Big Bang. Well, suppose you think about this in pictures and look at images of the cosmic microwave background. In that case, you basically see something like a baby picture of the universe. 13.2 billion years ago. About 200 million years after the Big Bang, large clouds of hydrogen and helium collapsed under gravitational attraction, forming the first stars. These stars clumped together to form the first galaxies. Nuclear fusion started inside the stars, where hydrogen atoms fused into helium atoms, releasing significant light and energy. This period is known as the epoch of reionization. Before this, the universe was in the cosmic dark ages, a time with no stars or galaxies shining to light it up. The formation of these first stars ended this dark era and began the universe's light era. Light from the first stars made the universe more transparent. This was the major step in universe evolution, setting the stage for more complex structures to form. 12.8 billion years ago. It wasn't until about 1 billion years after the Big Bang that things really started to get interesting. At that time, small galaxies began to fall together into bigger ones and galaxy clusters. This falling process helped in the creation of the large, complex structures seen in the universe today. In those growing galaxy centers, supermassive black holes formed that are incredibly dense with an enormous gravitational pull. Some of the black holes forged quasars that blaze with incredible brilliance, allowing them to be seen across vast distances. In fact, quasars glow so powerfully, they become some of the brightest things in the universe. As more galaxies and clusters formed, the universe began to resemble one giant cosmic web in which filaments of gas and dark matter connect huge networks of galaxies together. 4.6 billion years ago. About 4.6 billion years ago, within the galaxy Messier 31, popularly called the Milky Way, a huge cloud of gas and dust began collapsing under its gravitational force. Through this process, our Sun and its planets were uniquely formed, including Earth. Scientists refer to this as the solar nebula theory. With the collapse of the cloud, spin began, and it flattened into a disk shape. Most of the material collected in the center to form the Sun, while other bits of gas and dust clumped together to form the planets, moons, asteroids, and comets. We describe such a spinning disk as somewhat like a cosmic pancake with the Sun in the middle. The birth of the solar system was an important event because it set in motion a course that eventually led to life on Earth. Over millions of years, the solids gradually cooled and assumed shapes that became the variety of planets they are in today's solar system. 3.8 billion years ago. It is estimated that about 3.8 billion years ago, life started on Earth in the form of small, single-celled organisms that dwelled in the oceans. The first forms of life were quite simple, but at the same time, very crucial, because they are the first indications of life on Earth. These will, over time, amount to billions of years and evolve into more complex living things. Maybe the first giant leap was about 2.4 billion years ago, when some of these unicellular organisms evolved to be photosynthetic, that is, able to generate food from sunlight and provide oxygen as a byproduct. Oxygen started accumulating in the atmosphere due to production, making it possible for more complex life forms requiring oxygen to survive. Gradually, this excess oxygen produced higher forms of life, such as plants, animals, and finally, human beings. 2.4 billion years ago. Around 2.4 billion years ago, tiny photosynthetic bacteria started to produce enormous amounts of oxygen through photosynthesis. These bacteria resided in the oceans and used sunlight to make their food. In doing so, they released oxygen as a byproduct. This event is now known as the Great Oxidation Event. Before that time, very little oxygen existed in Earth's atmosphere. The oxygen began building up in the atmosphere from the continuous production by these bacteria over time. This was important because it provided the means to develop more complex life forms known today, which require oxygen for survival, known as aerobic organisms. It was by these increasing oxygen amounts that diverse ecosystems started forming. Arcing from this change in the atmosphere, it became possible to show a range of life forms, including plants and animals, developing on Earth. 600 million years ago. The most astounding thing that happened on Earth sometime around 600 million years ago was something called the Cambrian explosion. During this period, there was an enormous increase in the variety of life forms. Before this period, most organisms were small and simple. Many new types of animals emerged abruptly. Most of the ancient relatives of modern animal groups, like arthropods and mollusks, appeared now. These new animals had different body shapes and structures, such as shells and exoskeletons, that further helped their survival in different environments. This was really the setup for the modern complex ecosystems. With this many new life forms quickly undergoing evolution through the Cambrian explosion, it sometimes seems nature itself was conducting a great experiment of variation that brought forth today's diverse and colorful world of living things. This explosion of life proved very critical, since it led to the development of complex food chains and interactions among species that would shape the future of life on Earth. 65 million years ago. About 65 million years ago, a large asteroid crashed into Earth near what is now Mexico. The impact was so mighty that it fired gigantic fires and tsunamis and generated an equivalent of a nuclear winter when dust and rubble blocked the sun for months. This event of the Cretaceous-Paleogene extinction event took the dinosaurs and many other species to extinction. With the extinction of the dinosaurs, mammals had an opportunity to evolve and finally thrive. They were few and small, hence nocturnal during the dinosaur era. It was several million years before mammals diversified and increased in size until most of their species became established, including the primates, a precursor to the human rise much later. It was an extinction event that changed the course of Earth's history and allowed mammals to become the dominating animals on land, finally paving the way for a new civilization of humans. 200,000 years ago. It was around 200,000 years ago that the first modern humans made their appearance, in essence Homo sapiens, in Africa. These early humans started spreading all over the world until they reached every continent except Antarctica. Among the things that made Homo sapiens special were the ability to use tools, develop language, and create art that set them apart from other species. While doing this, in moving, they developed adaptations to several environments and climates. As time progressed, human civilization started developing. People started to live in groups, thus developing complex societies. They built themselves shelter, made clothes, and began farming so that they could stay in one place rather than roam continuously in search of food. The biggest step was language development because it let humans communicate and express their thoughts while passing on knowledge from generation to generation. The ability of creative thought and self-expression was definitely a unique aspect of them, seen through their art of cave paintings and carvings. These types of innovations have led to the sophisticated cultures and technologies today. Present day. The universe is expanding at an accelerating rate to this very day, fueled by something called dark energy. Scientists do not understand dark energy, but they do know that it is what causes galaxies to move away from each other more and more quickly. By observing the universe with sophisticated telescopes, such as the Hubble Space Telescope and other Earth-based instruments, and analyzing, scientists look for signs regarding the origin and composition of the universe. They study distant galaxies, cosmic microwave background radiation, and other cosmic phenomena to piece together what happened to the universe during its billions of years of evolution. For many years, scientists have been working on the cosmic clues left behind, which point to the composition of the universe. It contains about 68% dark energy and 27% dark matter. The rest, 5%, is what we can see, from stars and planets to galaxies. One of the greatest challenges of modern astrophysics has to do with understanding dark energy and dark matter. The more we study the universe, the more each new discovery serves as another piece in the puzzle of the universe's past and as a window into its future.